previous video, we had learned about the genesis of the periodic table, which means that we learned about various periodic tables that were proposed before the modern periodic table. So in the year, in the end of the 19th century and the beginning of the 20th century, there was a lot of discovery in terms of chemistry. Scientists had discovered the existence or the presence of subatomic particles, that is the electron, proton, and neutron. And before that, they didn't. They assumed that atom was indivisible in nature. So in 1913, Henry Moseley discovered there was a relationship between the X-ray spectra and the atomic number. So what he observed was that the graph which was plotted against root mu, which is the frequency, against atomic number was a straight line, and whereas when it was plotted against the atomic mass, it did not give a straight line. So that's when he realized maybe the atomic number should be considered and not the atomic weight or mass. So atomic mass. So till now, in all the periodic tables that we've come across, most of them consider the atomic weights or masses. And now they had discovered that there's something new called the atomic number after the discovery of our subatomic particles. And so the modern periodic law was proposed. It states that the physical and chemical properties of elements are periodic functions of their atomic numbers. In Mendeleev's periodic law, if you remember, pretty much it was the same sentence, but it had the atomic mass as the words in the end, because there the atomic mass was considered. Now, so based on this, there were various periodic tables which were proposed. As you can see, I've put forward a chemical relationship and the periodic relationship. This is a periodic table where you have a circular one. And this gives us the electronic configuration of elements, whereas this is also another variation of the periodic table that we already know. But this is the long form of the modern periodic table. And this is one of the most widely accepted, or rather widely used ones. Each of them might have a variation in the property that they're talking about, but the modern periodic table helps compile all the properties and gives us a better understanding of the same. So first of all, the periodicity is dependent on the electronic configuration as well as the quantum numbers. So obviously the electronic configuration in turn affects the chemical as well as the physical properties. I think at a later point in this chapter, we'll be discussing about the various properties, and that time you'll find it more clearer. And as we know, the quantum numbers is what decide the electronic configuration. So obviously, each of these elements, the quantum number is considered. So in this periodic table, as you can see, first of all, the horizontal rows are called as periods. One thing I'd like to point out right now is that in Mendeleev's periodic table, when we discussed, I said that this is periods, but no, it's in Mendeleev's periodic table, the rows are called as series and not periods. So in the modern periodic table, the horizontal rows are called as periods, and the vertical columns are called as groups. In the older versions of the periodic table, I mean, if you search for it and check it out, you will see that there are Roman numerals on the top, but over the course of modification, you can see that they are numbered as 1, 2, 3, 4 to 18. So you have 18 groups, and each of these are very specific to their properties. We'll be discussing that later on. And you have about 7 periods. Now, the first period consists of just 2 elements. The second, that is hydrogen and helium. The second and the third period has 8 elements. The fourth and fifth has 18 elements. And the sixth and seventh has about 32 elements. The lanthanoids and actinoids have a separate spot in the periodic table down here. So In the next, so we'll be discussing the electronic configuration of the elements and how we can determine, or rather how we can understand the electronic configuration just from the periodic table in the coming few videos. So in this video, we learned about the modern periodic law, according to which the physical and chemical properties of elements are a periodic function of their atomic numbers. And here in the modern periodic table, we are considering the atomic number. And the long form of the periodic table is the most commonly used one. The horizontal rows are called as periods, and the vertical columns are called as groups. And we will be discussing in detail about how the electronic configuration varies with respect to each group and period. In the next video, we will be learning about the nomenclature of the elements with atomic number more than 100. So do check it out.